sigma bond in the lowest energy, then it goes to the highest energy. Um, then there's like two types. In the highest energy, it's called sigma anti. I mean, like sigma star bond, and lowest is sigma bond. Um. Yeah. I know, like that. And what's the second question?
How is it different from hybridization?
Hybridization.
Hmm. Like in molecular orbital theory, what is happening? Two atomic orbitals are combining and giving two molecular orbital of different energy. How is it different from hybridization? Is my question clear?
Yeah.
Hmm.
Just a minute.
Yeah. Go through the notes. You have the entire cheat sheet. You can use that.
Yeah. Okay.
Hmm. Go ahead.
Um. Okay. Um. The molecular theory is like two atom makes a different molecule with different energy, right? But hybridization is mixing of orbitals. Um, it's
Complete
just like
sentence again.
mixing of orbitals within the atom to
And
form a hybrid orbital.
what about the energy of those hybrid orbitals? Are they similar to the ones from where they have been produced, or they have a slightly different energy? And if they have different energy, where would it lie? In between, high, low?
Oh yeah, the hybrid
Yeah, hybrid.
high-low. Isn't the high-low in the molecular theory?
But if you look at the hybridization, we are getting a single orbit of equivalent energy. See, this was a higher energy orbital 2p, 2s is lower.
Huh?
We are getting somehow in between, equivalent energy orbital, right? One more thing I told you in the previous class, what is the reason for the hybridization? Why the side atoms are not just directly getting attached to a central atom? Why our central atom has to produce the hybrid orbitals? What if it is not producing the hybrid orbital? How would it affect the overall molecule? I told you with a specific like journal example, basically. You must remember, I hope.
No, I don't know. Remember.
Okay, I think you are enjoying your vacation a bit more, little bit much, I guess. Are you not studying?
I'm not even enjoying the vacation.
So what are you doing?
I can't even get some sleep. I'm just
Like,
family
why?
issues, I guess.
How? Okay, family issues. No problem. You need
Too
to like,
much.
still you have to find time, right? Because
Yeah.
studying is important.
Yeah, I'm gonna start studying.
So
I
let
just
me tell
need
you,
time.
mm, please find time, right? Okay, so let me tell you again.
Mm.
Uh, if you have to form a molecule, side atoms are going to contribute and attach to the central atom, right? They are going to
Yeah.
share the electrons. If I have a choice, if I am a side atom, and if I have a choice to choose a energy orbital of lower energy or higher energy, which one am I going to choose? The stable one,
Sorry?
lower energy one?
Your voice wasn't clear. Sorry, say
Okay.
again.
Suppose I am a side atom and I have to make a bond with
Side
my
atom.
central, make a bond with a central atom, right? And
Mm-hmm.
I have two choices. I could either go for 2s orbital or I could either go for 2p orbital. Which one would I choose?
Yes.
The first one, 2s one, right? Because it is in lower
Yeah.
energy.
Yeah.
Suppose, suppose if there are four people like me and we all have to make a bond, so all of us will fight. So like all of us will fight for the
Yeah.
2s orbital. So it would create
Yeah.
some unlikely instability. So to avoid that, what our central atom do, it produces orbitals of same energy. So the side atoms won't have a choice. So they don't fight, right? Are you getting what I'm trying to say? To make
Yeah.
things simpler. So this is why hybridization is happening. So let us move ahead with the previous, like where we left in the previous class. We did a molecular orbital theory for simple molecules, and we found out the answer for why He2 molecule does not exist. So can you tell me why He2 molecule does not exist? Let me show you the answer. So you can simply see and tell me.
If you
Yeah.
use the formula,
Mm-hmm.
um, so BO is equal to half number of electrons in high energy state minus no, sorry, number
Mm-hmm.
of electrons in the low state, like the bottom area,
Mm-hmm.
um minus the high state.
Okay,
So
so
so in helium there's two
mm-hmm.
electrons, yeah.
Yeah.
So two electrons. Um so it's gonna go wait, how will it go to the up state, like the sigma star?
It will depend on the number of electrons. Suppose if you have four electrons, so automatically you will exhaust the 1s orbital. So you have to go for the next one. It will depend on the number of electrons. If you have only one electron, you will be able to easily fit it into the 1s orbital. If you have three,
Okay,
you
so
will
if
fit.
there's like four, you need to use the
Uh,
sigma star one, okay?
yeah,
Yeah?
if you have six, if you have six, you will go even higher.
Okay.
Right?
Yeah, this makes easy. Then two helium atoms has like four electrons. So we need to fit four electrons in one s orbital. So two electrons goes to the sigma 1s, and two electron
Mm.
goes to the sigma star 1s. Correct?
Yeah, yeah.
So if we count the electrons in the sigma 1s and sigma star 1s, you'll get
Mm-hmm.
half
Okay.
into
Mm-hmm.
2 minus 2, as I said, the formula. So it's gonna be 0 by 2 and it's gonna be 0. So that means it doesn't exist.
The bond order is zero. If bond order is zero, there is
Yeah.
no bond, right? So in the
Yeah.
molecule won't
Bond
exist.
order is 0. Yeah.
So similar examples are for Be2, Ne2. Similar
BE2.
to our helium 2, our beryllium 2 won't exist because the bond order is going to be again zero. For neon 2
Yeah.
is also the same. And a homework for you, you will be able to do it easily after we have
Mm-hmm.
gone through the 2p orbitals now. You will find the bond order is coming as zero. So you will have to do this.
Mm.
Let us talk about the 2p orbitals from like for today's class. I told you what is HOMO, HOMO, and what is LUMO. So can you tell me again? I'm going to take the same example, the one which I explained in the previous class. Let us see whether you remember it or not. So if you have this Li2 molecular orbital series, right? So out of
Mm-hmm.
these orbitals, molecular orbitals, which one is HOMO and which one is LUMO? Can you tell me?
There's two. Li2, right?
Yes, it is Li2. You are making two lithium atom and you are producing a Li2 molecule.
Okay. Between which one I have to say? Which one is Lumo and which one is Homo?
You have to choose from molecular orbitals. First of all, do you know what are molecular orbital and what are atomic orbitals? So if I ask you, can you differentiate? If I am, see, I am marking This, this, and these. Which one is molecular orbitals and which one is atomic orbitals? Which one are atomic?
The blue one is molecular orbitals,
All right. Okay. So you
and
have
the
to
red
choose
one
from
is
blue.
atomic.
So you have to choose from the molecular orbital. So which one is highest occupied molecular orbital? As the name suggests, which molecular orbitals has the electrons? Which one is the highest molecular orbital which has electron?
Yeah, sigma star 2s,
Okay.
highest.
Yeah. In sigma star 2s, are you able to find any electrons? It is empty here.
Yeah, so the highest is the sigma 2s.
Yes, sigma 2s, right. Homo is sigma 2s. So what about LUMO?
Mm-hmm.
Lowest unoccupied molecular orbital.
One sigma s.
No, it is your sigma star 2s. By LUMO, we means lowest unoccupied molecular orbital, which,
Lowest or highest?
see, initially I was talking about HOMO, highest occupied molecular orbital. Are
Mm.
you seeing this term?
Yeah,
This is occupied, highest occupied, right? So highest
yes.
occupied is sigma 2s,
Mm-hmm.
and lowest unoccupied is which one? Lowest unoccupied is this one. This is unoccupied, right?
There could be highest unoccupied one.
No, we don't use that term. We only use HOMO or LUMO.
Okay then.
Is it clear?
Yeah, I understand. Yeah.
Good. So let us move ahead and let us bring the p orbitals as well. So I told you another thing in the last class, as we mentioned the outermost electronic configuration for most of the cases for simplification, right? Rather than writing
Mm-hmm.
the entire electronic configuration, what we do? We just simply write the outermost
The
one,
valence one.
valence one. So if you have given in your exam to write, or I would suggest to go through all the steps, right? It would help you to understand it better. So avoid that. Write the entire molecular orbital. I haven't shown it here, but
Mm.
you have to write it in your exam. Suppose we are talking about B2 molecule, right?
Yeah.
B2 molecule. So in boron, how many electrons are there? Total number of
Boron.
electrons. Yeah.
Is it, wait, is it 9? No, it's not 9. Four, four, four,
Nope. You are just like missed one now, like you are short one number. It's
5.
fine. Yeah.
Which one is 4?
It's hydrogen,
Beryllium.
beryllium.
Yeah, I got confused between the B brothers.
No, if you see now we know the number of electrons. So this, try to think it. If you have doubt, please ask me
Hmm.
again. This 1s2 and 2s2 is going to look similar to this one or not? In our 1s2,
Yeah,
all the electrons are filled. In our 2s2, the electrons are again filled. So we are
yeah,
not going to show this again. I am not going to show this again. You can consider
yeah.
it before reaching this stage in this molecule. I have filled
We're
them.
gonna cut the whole thing.
I have like, we have filled them already. We are now talking about the outermost shell. So
Yeah,
in
I
the
know.
outermost shell, which is P, and the outermost shell is 2s and 2p, but outermost subshell is 2p, right?
Yeah,
So how we are going to show the p orbitals? We have 2px, 2py, 2pz, 2px, 2py, 2pz. In the p subshell, how many electrons do I have? One. So in one boron atom, I have shown one electron. In other boron atom, I have shown another electron. Is it making sense? The way
yeah, yeah.
we were applying in the previous cases. So
You
now
didn't use box.
it, like, you can use the box as well. I was lazy, so I did it, but you should,
Yeah.
right? Oh, I think that's
Mm-hmm.
good. The splitting, or you can say from these two atomic orbitals, these two p atomic orbitals, the molecular orbitals that we are going to get are in this order. We are going to get pi 2px, pi 2py in the lower energy state. Then we will have sigma 2pz. You have to learn this, right?
Yeah,
The below one are pi 2px, pi 2py, then sigma 2pz, and you have to just write them again with a star sign. So this is how your B2 molecules, p orbitals, p molecular orbitals are going to look like. You will start with pi 2px, pi 2py, sigma 2pz, then you will show the respective anti-bonding orbitals in same way. You just have
Mm-hmm.
to show the orbitals and you have to put the star mark, right?
Yeah.
So this is how your molecular orbitals for p substance are going to look like. So you have two electrons.
PZ is the highest.
Yeah, sigma 2pz is having slightly higher energy, right? So it is a bit unstable. Okay,
So
it is going to
LUMO
change.
is uh, P star PX, right?
No,
2PX.
lowest LUMO means lowest unoccupied molecular orbital. Which one?
Yeah.
See,
Oh, okay, okay. Yeah. Yeah, I'm sorry. I didn't look at this one. Yeah, the LUMO is sigma 2 PZ.
very good. Which one is HUMO then? HOMO, I mean.
Homo. Homo is pi 2px and pi, no, the highest, right? 2p
Yeah.
pi 2py.
Think again. The highest occupied molecular orbital. There could be two.
Yeah,
Like
highest
occupied. Which orbitals are having electron? Occupied.
which electrons
Which orbitals are having electrons? Which molecular orbitals are having electrons?
pi 2x and pi 2y.
Yeah, those are HOMO then. Highest occupied
But
molecular orbital.
they are two different orbitals.
But they have same energy, right? They are on the same energy
I
level.
mean, yeah.
So
Oh,
there
okay,
could be
okay, okay.
more than one homo. It will depend on the
Okay.
cases, right? So now what we are going to do? We are going
I
to
thought
calculate the
like
bond order.
since we're gonna add electrons to px first, then py, that means px is much more lesser than
Uh,
py.
so is it clear now? Like
You
we are
know,
talking in terms of axis. They are both
yeah,
are lying on the same level. Like if the number is one, they are both on the one number.
yeah, I
They have
understand.
same energy. So now again, we are going to calculate the bond order because bond order is going to help us understand which type of bond
Hmm.
is present between the two atoms. If bond order is one, there
Yeah,
is a single bond. If two, then double bond. If three, there is a triple bond, right? So now
yeah,
the formula is half bonding molecular orbital and anti-bonding
uh-huh,
molecular orbital, right? So how many
yeah,
electrons are present in bonding molecular orbital? And the bonding molecular orbitals are the one which are not having a sigma star sign, right? So how many electrons
yeah.
are there?
Um, there are zero anti-bonding element, right?
First, tell me about the bonding molecular orbitals. How many electrons are there?
Um, okay.
Hmm.
Hmm. I want to say two, but I
It
also
is
want to say one
Y1.
because it's in the same axis.
It is in the same axis, but we are talking about the number of electrons. They are two.
Okay, then two.
And I think you are getting confused because of this. It is like this. Now I hope it might make more sense to you.
No, I understand now. I understood everything now.
Okay. So it is
Yeah.
actually like this. So now the bond order is going to be one or not.
Yeah.
So the thing that you need to be careful here is the electrons are present in which orbital? Pi orbitals, right? Pi 2px and pi 2py or
Mm-hmm.
not. So the bond
Mm-hmm.
that we are going to get here is a pi bond, okay, not a
Yeah.
sigma bond, right? So this was just I want you to like look at it carefully because you might get confused. If there is a single bond, it is not always going to be a sigma bond. It might be a pi bond. It will depend on the molecular orbital theory, right?
Yeah, but what does that matter? Why does that matter?
Because suppose if you have a pi bond or a sigma bond, pi bond are relatively weaker if you compare them with sigma bond. So if you are
Okay,
talking
okay.
about B2 molecule, this it is not that stable. If you try to break it, it will break easily because the bond which is present here is a pi bond, not a sigma bond, right?
Okay.
So yeah. And one more thing that you should write somewhere because when we will reach the nitrogen, the atom with more than 14 electrons. So you will find, like you will say why it is happening. So write it somewhere. Till nitrogen, we observe sp mixing. I think I told you in the previous class what is sp mixing, and you must have forgotten it, right? Do you remember what is sp
Yeah.
mixing? Or it's gone?
Which one? Which one? Which one?
sp mixing.
SP mixing.
Yeah, sp mixing, s and p orbital mixing. I told you in the previous class that
Yeah, I know
whenever
that. I know that.
good. So I
In
will.
diagram, right?
Hmm. I'm
Yeah, I
going
know
to
that.
use
I know
it.
that.
I'm going to use it. So just keep this in mind. Right. So we also know how to calculate the magnetic moment, right? This is the formula N plus 2. Bohr magnetron is what? SI unit.
Um,
N is what?
no.
Number of electrons.
N is number of electrons. Yes.
So 2 you will put here and you will get 2 root 2 the answer. This is magnetic moment, right?
Yeah.
They are going to ask you these kind of questions, so you should be aware. And I have seen people who understood this concept, but they did not write it down in their copy. They were not practicing making these orbitals, right? So they made mistake in exam and that took them some marks. So you should avoid it. You should practice making this orbitals, right? They might look simple, but when you are drawing them now, you will find it like why I am drawing this here and why not there. So you better like make mistake first rather than making them in exam. Okay.
Yeah.
Now let us talk about C2. Again, the same thing, but what is different here? Rather than having one electron, we have two electrons in our p subshell, right? And as we have two carbon atom, total number of electrons are how many?
Wait, just 1 minute. Oh yeah. Say again.
Right. I was saying it is just similar to the previous case, but rather than having one electron in our p subshell, we have now two electrons in our p subshell, right? So
Mm-hmm.
one carbon
Mm-hmm.
atom has two electrons in p subshell that I have shown like this,
Mm-hmm.
and total number of carbons are two. So total number of electrons are how many? How much electrons are we having here?
4.
Four. So it will
Yeah, I know
again
how to make
split.
this.
It will again split, and you will fill the electron as per Aufbau principle, right? You have to
Yeah.
apply all the principles, quantum number principle. Sorry, Aufbau, Pauli, and Hans. So like this, you will fill them halfly first, then you will do the pairing.
Yeah.
So what is the bond order here?
Bond order. Bond order is 2.
Good. And the bond that we are having is pi bonds or sigma bonds.
Pi bonds.
Good. Is it diamagnetic or paramagnetic?
Uh,
The answer is written over here. You have to explain why. Okay. Just don't tell me the answer.
okay. Dimagnetic.
Hmm.
Hmm. Because it's filled box, right? Because the orbital is fully filled.
Very good. Very good. This is your correct answer. Right. So what about this one? The previous one, it is
It's not
paramagnetic or
fully filled.
so para or dia?
Para.
Good.
It's not written there, right?
Hmm. Okay.
Yeah.
Uh, so what else is written over here? See, I have shown the two bonds as pi bonds. That's why C2 do not exist normally due to weak pi bonding, right? C2,
Yeah.
you generally don't see C2 molecule because the bonds that we are having here are pi bonds and pi bonds are relatively weaker, right?
Yeah.
Then we have C2 negative. You will do the same thing, but you will add two more electrons. So how will it look like?
Yeah.
The negative charge is two. So you will place one more electron here and one more electron here. You will show it like this, right? And you will fill
Yeah,
the
I understand.
electron.
Yeah.
It will look like this. So you should do that as an homework, right? Now, the thing, I think no, from oxygen you will place that. Nitrogen, it is again same, right? What is different here?
Yeah.
Rather than having two electrons in our p subshell, how many electrons do we have actually now? Three.
3.
and total number of electrons are 6. So we will fill the 6
Yeah.
electrons accordingly. Now, what we will observe? We will observe that our bond order is 3, and
Yeah.
we have 2 electrons in our sigma 2 pz orbitals. That means we have a sigma bond and we have a
Yeah.
2 pi bonds. So it is a triple bond, right? It is
Yeah,
a
I know that.
2 pi bonds and one
But
sigma
wait.
bond.
Um, but so if that means triple bond, then what about C2?
In C2, na, see, in C2, you did not have any electrons in your sigma pz orbital.
Yeah,
To produce a sigma bond, you need electrons in your sigma molecular orbital. If you look
yeah.
carefully, if you compare these two atomic orbitals, how they are different, tell me.
Mm,
In the
how
below
they're
one,
different?
we have 6 electrons. In the carbon one, we have
Yeah,
only 4 electrons, right?
yeah.
So, see, you just to clarify, are you talking about this case? This case C2 negative, C2 2 negative, or just simple C2?
No, it's simple C2, simple
Okay,
C2.
okay, okay. In simple C2, na, see, you have electrons only in pi orbitals, pi molecular orbitals. So the double bond that you are having na is only due to pi bonds. But when you are talking about N2 molecule, you have your pi bonds, but on top of it, you have
You have
sigma bond
one
as well.
sigma.
That is the reason N2 molecules is easily
But
accessible.
double bond should have a sigma bond. It's like sigma bond, then pi bond.
Mm, are you saying like I have drawn it like sigma pi, right, right, like this?
Yeah, and double bond is sigma pi, and single bond is sigma.
See, to clarify it now, let us go back and see the diagrams of sp hybridization, right? Because that will help you to visualize it better. Where was that page difference? Yeah, see, this is your this see, this one is causing the pi bond, sorry, sigma bond, right?
Hmm.
And these two unhybrid orbitals are causing pi bonds. So
Hmm.
two pi bonds
They are triple
like
bond.
this, and in between we have a sigma bond.
Yeah,
In three
it's a
dimension, it is
triple
going to
bond.
look like this. Is it making sense or like
Yeah,
the
this makes sense. This is a triple bond.
hmm. So this is the case in N2 molecule.
But my question is,
You are saying why it is not like this.
no, that's not my question. The thing is, we have learned that, uh, what is that? SN? Okay. Do you know SN? Remember SN?
Steric number.
Yeah, steric number.
Hmm.
It said that number of sigma bond plus number of lone pairs, right? Um,
Yeah. Hmm.
so even though there's like double bond or triple bond, we count them as one sigma bond because there's one sigma bond amongst those double and triple bond, correct?
Oh, I think I am getting what you are trying to say. You are relating it with VSCPR theory. While you were doing the calculation for calculating hybridization, you were coming across like this. Whenever you were finding two bonds, you were putting one sigma and other one pi, right?
Yeah, like that. Yeah, yeah, yeah.
See, those
But
molecules,
here there's two pi bonds.
because see,
How's that?
I get your question. Here, this molecule does not exist. This is the reason because both the bonds are due to the pi bonds. The molecules that you were dealing now while you were calculating the hybridization, those were the molecules which actually exist in a relatively stable form. So there you had the molecules which had electrons in their sigma bonds. The condition was the sigma bonds was present. It was basic condition.
Yeah,
Whenever you
sigma
will,
1 is present.
but have you ever came across to a molecule similar to C2 while you were doing questions on hybridization? Have you seen any question like C2 or B2? Not, I hope not,
Yeah.
because the questions that have been given to you now, those are the questions for the actual molecules. This is we are studying. Suppose somebody tells
This
you,
doesn't exist.
this doesn't
C2
exist.
doesn't exist.
Have you seen anywhere C2? Carbon is a solid carbon you can find in a solid form, right? But have you seen carbon in gaseous form? I am not talking about carbon dioxide, just simple carbon. Have you seen C2
No.
anywhere?
No, 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 no.
So what is the reason? The reason is the bonding is due to the pi bonds, right?
Oh.
Which theory explained this? This molecular orbital theory. I have written it as well.
Then
Uh,
what about the above one?
see, if you see this one,
Yeah, that
see
one, that one, that one, that one.
what I have written here. That's
B2.
why we do not see B2 much. It do not exist due to weak pi bonding, which is shown by MOT. Are you able
Oh.
to are you able to read my writing?
Yeah, yeah.
Tell me what is written over here.
Okay, that why we don't act B2
We do not
much, comma.
see.
That's C.
Yeah, S double E.
Okay. It donut donut
It's do not.
do not
Hmm.
keep some distance exist due to weak pi bonding with with
Which
is
which
which is should be by MOT.
showed. They are
Okay.
shown.
Um.
Okay. So
Yeah.
you will find every answer. Whatever question you are
Mhm.
having now, everything is written in the PDF. So you should
Yeah.
make a
If
habit
I
of
can read
going to
them.
my you should make a habit of reading my PDF, right? That's the only way you will
Yeah.
be able to understand my writing. So why does N2 molecule exist? We usually see N2 molecule, right? N2 gas is pretty common. Why does it exist? Because it has a sigma bond coupled with pi bonds.
Mm.
So it is a strong bond. I hope it is
But this
making sense.
exists. This
Yeah,
exists, yeah?
this exists.
And to exist.
Hmm.
Because there's a sigma bond.
Yeah, coupled with pi bond. Sigma bond is strong, but
Yeah.
additional pi bonds are making it even stronger. All right,
Okay, I understand.
so now we are going to change something. From oxygen, the sp mixing stops, right? Here we don't have sp mixing. So in the previous case, we were writing our these orbitals here and the sigma 2pz above, right? So what we will
Yeah.
do, we will just replace them and everything is same. Apart from this thing, everything is same. So till nitrogen,
What is
you
this?
will
What is this?
see. Let me just go back. Just mixing it. See, uh, till 14 electron. If you have
Yeah.
a atom, if you have a molecule where there are 14 electron or less than 14 electrons, so sp mixing will be
Mm-hmm.
present. S and p orbitals will be close enough to each other. There they will have they will allow themselves to mix with each other. But as you are moving to higher number of electrons, higher molecules, suppose you have reached oxygen. Oxygen has more than 14 electrons. So now
Yeah.
the s and p
16.
orbitals are far apart from each other. So the mixing that was present till 14 electron is absent now. So due to absence of sp mixing, what we will observe? These two orbitals will exchange their places,
Oh,
right?
yeah.
You will not find the answer.
Above.
Hmm.
More if the atom is more has like no, if a molecule has more than 14 electrons, then we will consider that sp mixing.
No. If the If the electrons are less than 14 or exactly 14, we will consider sp mixing. If the
Okay.
electrons are more than 14, we will not consider sp mixing.
Okay.
Right?
Okay.
So, so
So the
now,
lowest orbital is PZ.
now they will exchange. See, here it was like this. Now it will be exchanged and it will look like this. The rest is same. The rest is same.
See,
Okay. So now in oxygen, the p orbital has how many electrons?
in oxygen, there's 16.
In the outermost shell?
Outermost shell, there's like um 6.
6. Yeah. But in p subshell, there are only 4. Right? It is like
Mm-hmm.
this, na? 2s2, 2p4. So I am talking
Yeah.
only about p subshell. And again, I would like to tell you something. The 1s2 and 2s2 molecular orbitals are shown. I have like they are present. I haven't shown them, but right?
Yeah, I
They
know.
are present.
You said we are only considering the valence.
But if you are writing this in your exam now, to be safe, show the 1s and 2s orbitals as well. How they will look like? They will simply look like this. If you are showing 1s
But you
orbital,
said you just need to show the valence one though. You just said that
what I said to be safe. We do not
to
know
be safe.
how your teacher is going to mark, right?
Hmm.
In board
Or should
exam,
I just ask ma'am?
you can ask, you can ask.
Okay.
But if you have to show, you will show them like this. The orbitals are already occupied completely, so you will show them like this, and then you will start filling the
How do
same.
I ask ma'am? Like, what do I ask?
Show your ma'am. Simply ask her. Say, ma'am, I am solving molecular orbital questions, and
Hmm.
can I just directly represent the outermost subshells molecular orbital representation rather
Oh
than
yeah. Okay. Okay.
showing
Okay.
all
Okay.
of
Okay.
them.
Okay.
Right? So in oxygen, we will do it like this. Now, one oxygen has 4 electrons in p subshell, another will have 4. So how many electrons do we have in total? 8.
Yeah.
We will place the molecular orbitals in this order and then we will start filling them. So we have 6 electrons. I will
Mm-hmm.
place 2 here, then I will go like this,
Mm-hmm.
half fill, then completely fill. It is again occupied, then I will go for them. So what is the bond order for our O2 molecule?
Bond order. Hmm.
6
3.
minus 2? No. See,
Oh
half
wait, that's 6. Okay. 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 4.
divided by 2. 2.
Mm-hmm.
Is it clear how is it is coming
Yeah.
as 2?
Yeah. 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 Yeah.
So O2
Yeah, it's clear.
molecule again.
So the bond is triple.
No, the bond order is 2. Double bond.
Double bond.
One more thing, you might be having a doubt like we have this should be clear why the sigma bond is coming, but why
Yeah.
only
Yeah.
one
Yeah.
pi bond is coming? Is there a doubt like that? Like that?
One pi bond.
Why one pi bond is coming only?
Yeah. Why one pi bond?
See,
That's what I
if
said. Is it triple bond? You just said two.
see, are you looking these two?
Yeah.
When we have bonding molecular orbital and we have anti-bonding molecular orbital, they are opposite. They will always try to cancel each other out. So
Oh, okay. Okay. Yeah. I understand. I understand.
these two electrons are causing,
If we minus them.
hmm, it is
Yeah.
actually looking like this. Right? I
Yeah.
must have written it somewhere as well. See,
I
everything is
think.
written in this PDF. Let us see, will you be able to decode it or not? What is written?
Okay. C in sigma 2 PZ BMO
Not in that order.
2 yeah um 2 electrons, but in sigma star 2 pz a anti bonding molecular orbital 2 electron 2 theta. What is that?
Zero, zero.
Oh, that's zero to 20, 2010.
No, 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 zero. It is written as zero. ABMO
Oh,
zero electron.
zero. Oh, let the okay, okay, okay. Zero electrons. That is bonding molecular orbital are making bendy
Bonding, making bonding
bonding bonding
without
without restriction.
restriction.
Uh, from
Nominalization.
ABMO. Okay,
Sigma star to PZ.
sigma star to be said. Sigma star to be said, but in case of one sigma bond, BMO to pi to be said to pi 2py, there are four electron, and other another side in two pi to
On other
pi
side.
star on other side
Mm.
pi star to p
ABMO.
ABMO ABMO them then there. Okay, that's
There
there.
are. Mm.
ABMO there are two electrons. Hence, two electrons of ABMO restrict two electrons, a lot of two electrons, from four electrons of BMO. Remain far bond.
Remaining for
Uh,
bond formation.
what?
Remaining for bond formation, two electrons of BMO. See,
For bond formation of two electron of PMO by 2p.
let me tell you in simple terms.
Okay.
These, whenever we have counterparts, suppose AB or BMO orbitals and ABMO orbitals. Suppose
Mm-hmm.
here we have only sigma bonding molecular orbital. In sigma
Yeah.
star, in anti-bonding molecular orbital of sigma 2pz, we don't have any electrons. So it is not getting restricted by anything. It do not have its bad counterpart, right? So it
Yep.
is existing without any trouble. But when we are talking about these pi2px and pi2py, they have their bad counterpart, right? The anti-bonding orbitals. So they are going to cause restriction in two electrons. So it is appearing as there are four electrons in our 2px and 2py molecular orbitals. But in actual, how many electrons are actually participating in bonding? Am I making sense?
Like eight.
No, 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 no. See, suppose I'm Adnan,
No,
right?
I understood that part. I understood this part, the anti-bonding and the normal bonding. I understood that part. It get cancelled out, so there's
Very
only
good.
one pi bond.
Because only
Yeah, I
two
understood.
electrons are actually participating in the pi bond, right? And one will
Yeah,
contribute half, the other will also contribute half, half pi and half
yeah,
pi. It is one pi bond, right? So this was all about it.
yeah.
Okay. So F2 for F2, 2p this and this also. Blah, blah, blah. Okay. So no spin mixing. You can calculate the F2 one easily. Same thing. You will just have to increase one electron. Now let us do a trick as well. So you don't have to
Mm-hmm.
always draw these big molecular orbitals. So how can you do this? You will write like this: 8, 9, 10, 11, 12, 8 to 18, right? In this order. Then you will say your 8 electrons, that mean Be2. Your 10 electrons means
Mm-hmm.
B2. This is C2, this is N2, and this is O2, and this is F2. Right?
Okay.
Now, this bond order, in your exam, they are directly going to ask you, what is the bond order for this molecule? What is the bond order for this another molecule? So this is a way, like, what is rectification type thing?
No,
Rote memorization.
no,
Do you know the term ratta or not?
no. Zeta?
Ratta.
No, no, no.
Okay, so
Is it like I have to know that?
no, I thought you might know because it is a very common word used by students in India. So,
Yeah,
okay,
but I'm not from India.
okay, no
No,
problem.
I'm from India, but I'm not in India.
No worries, no worries. So, this is a trick. So, for
Yeah.
B2 molecule, you have bond order 0. Then the bond order will increase in a steady way. 0, 0.51, 1.52, 2.53.
Mm-hmm.
The moment you reach C, then you will decrease it. 2.52, 1.51, 0.2. So you can learn it. It will help you to it will help you to write the bond order even without the help of your molecular orbital theory. So you will write the number 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. You will mark
Mm-hmm.
8 for BE2, for 10 B2, C2, N2,
Mm-hmm.
O2, and O.
And why there's nothing in the middle, like 9, 11,
Because
13?
because we don't have
They do
molecules.
not exist?
They do not exist.
Okay.
We don't have molecules with such electron numbers. Right?
Yeah. Mm.
So this is how you're going to do that.
Two. No, C2 doesn't exist.
C2 does not exist, but you can hypothetically make a combination. You can hypothetically study like what if we are combining C2 molecule. With the help of molecular orbital theory, you are finding the answer why C2 molecule does not exist. And you found out
Mm.
that the bond order 2 which we are getting, it is contributed by pi bonds only. And pi bonds are very weak. That is the reason it
Mm.
does not exist. Right? How do you know
Yeah.
C2 does not exist? Because of molecular orbital theory.
Yeah.
Okay.
And does F2 exist?
F2, I think it is very unstable, so the answer is no way. Uh, for the we have to draw the pura ka pura wo molecular orbital diagram for this. It is highly unstable. It exists, but not for that much of time of period. Half-life is very low, right? It
Mm.
exists, but very short amount of time. So now, hmm, what we have here? A question for you. Just try to think about it. You don't have to use chemistry here. You have to use your general knowledge, just right? So try to think. If I am saying what should be the bond order for Be2 negative molecule? So how can you answer it with the help of this
BE2,
data? Hmm. Be2
okay.
negative.
BE2 negative.
Hmm.
BE2 negative, yeah. Okay, just a minute. 1.
How?
We're adding 2 electrons, right?
Good. Very good. Very good. So you have related it. The electrons for B2 are 8. If you add two more electron, it is 10. For 10, we have one bond order. Good. Very good. This is your correct answer, right?
Yeah. Wait. Oh, yeah. Yeah.
Okay. So you can use this table to make things easier for you.
Mm-hmm. There's
So
two
you must
N2s?
where
Like
to enter?
20 and 14?
Where?
What's 20 then?
Where is
Look at
20?
20.
This is
Like
Ne2. Neon.
Na2.
Neon. Neon.
Ne2. Ne2.
Yeah.
But Ne2 doesn't exist.
The reason is
0. Okay. Wait, if it's 0, but B2 exists. No,
uh,
wait, B2 does, BE2 doesn't. Oh, yeah, you're correct. You're correct. Yeah, yeah.
so shall we move ahead?
Yeah.
So you don't have to go through this because they will not ask you. Every molecule that has see the question is here. The diatomic molecule that has bond order of 1. Which molecules have bond order 1? So it is a multiple like
Bond
MSQ
order
type
1.
question. So there are three options, and with the help of that table now you will be able to answer it very easily, right? So
Yeah.
move on. Why would you have to have different molecular availability? See, I have explained the SP mixing thing here, but
Yeah.
they are not going to ask you directly the SP mixing. This is just for your understanding. So you can look this. It is written over here. What is happening? Till 14 electron, the gap is like this. The gap is low, so the characters can exchange it. If the gap is low, the SP mixing can occur. But if the gap is very high, then the SP mixing will stop. This is the case for electrons, sorry, molecules with having higher number of electrons than 14, right?
Yeah.
So this was the last topic, I guess. I think I should tell you some more questions. Uh, Let me check. Give me a second. Let us do some questions. In the next class, we will start in the thermodynamics. There is two chemical molecular orbitals. You have a test today, I guess, or have you given the test?
Which test? Oh yeah, that weekly test.
Yeah, yeah. Are you done with that?
I have scheduled it to Saturday. Saturday.
Oh, okay.
6 p.m.
I think I know what I missed. Just give me a second. They will ask you the electronic configuration as well. So let us do that. I have dropped the chemical. Just give me a second. Ah, see. See, one thing that we missed over here is they will ask you to write the electronic configuration. So you don't have to do anything special here. Uh, where is that?
Electronic configuration. Why?
Yeah, see,
And
in the
won't it be easy?
it is very easy, but you have to use some new terms here. Suppose in the previous cases you were using 1s2, 2s2, right? But here you have
Yeah.
to use the respective molecular orbital terms. The molecular orbitals are sigma 1s, sigma star 1s, right? So rather than using simple 1s, 1s2,
Oh, like
because
that.
those were for atoms. Now we are talking about molecules. So we have to use the molecular orbitals, right?
So what is the change now?
It is the same. You have to just see for the how you are
We
arranging the
just have to
molecular.
use sigma and pi.
See, suppose you are starting with let me take an example. Can you take
Sigma
a
1s.
can you take a screenshot of this so you have a reference while I will talk about it?
Yeah.
Just take a screenshot of it. Are you done?
Yeah, done.
Okay, so let us do. Hmm. Suppose they are asking you to write the molecule electronic configuration for H2 molecule. So how will you write it? How many electrons are there for H2 molecule? For molecule there are two electrons or not?
Yeah.
Both of them are present in sigma 1s. So you
Yeah.
will write it like this. This is your electronic configuration for H2 molecule, sigma 1s2.
Oh, like that. Okay.
Let me write it as well. Electronic configuration. So if we talk about He2, so what is the electronic configuration for this? Sigma 1s2 and sigma
One is star
sigma star 1s2. This is your
2.
electronic configuration for He2, right?
He2. Okay.
For lithium, you will start by for electronic configuration, you have to write the entire electronic configuration. You will start with sigma 1s1. Oh, sorry.
Yeah.
Uh,
One
sigma
is
1s2.
sigma 1s2, sigma star 1s2,
Then
then
sigma,
sigma 2s2,
right? For
and
lithium, we have to do.
oh yeah, yeah. What about the star?
It is empty.
Okay.
So for this, You will write it like this. Sigma 1s2, sigma star 1s2, right?
Which one is this?
B2 molecule.
B2. B2.
Now your star one will
4.
also come.
Okay. Yeah.
Right? Now
And
this.
5.
For,
So 10. So I'll say. I
mm,
have to try. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2,
mm,
then sigma uh p
no, 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 not sigma p.
x.
It's pi 2px.
Huh?
Pi 2px, right? Not sigma.
Oh yeah. Z is okay, okay. Pi 2 px 1.
1. Then pi 2pz, pi 2py.
Um yeah, why did you add Z?
No, like I mispronounced
Made
it.
a mistake.
It was is y.
It was by mistake. Yeah, okay.
Okay. So let
Oh, you
me.
have to do like that. Okay.
I think it is pretty simple, right?
Yeah.
Okay. So let's do some
Okay,
more.
but then what about it has if the electrons are more than 14?
We
Like
are going to do
no.
all of them. See, let us do this one as well.
Okay.
How will it
C2.
start?
16, yeah. 1 s 2 sigma star 1 s 2 sigma 2 s 2 sigma star 2 s 2 pi. Wait, just a minute. Pi um 2p 2x, then
2px, 2p, 2x. Okay,
2px,
2p,
yeah,
2x.
2x, um then pi 2p 2y,
Good.
then z won't come because it's empty.
So similarly, we will do the next one, right?
Mm-hmm.
So what we are going to do here is we will just have a sigma one as well. Now, how will you say? We will say sigma
Pi
2p
I mean sigma 2pz,
2.
2p 2z.
Okay.
Yeah.
Now you were asking about what if the SP mixing is not here. So you will now
Yeah.
fill your sigma 2p at first. Let us do this, right?
Okay.
The sigma,
Sigma 1 s 2,
mm,
sigma star 1 s 2, sigma 2 s 2,
sigma star 1s2,
1 s 2,
sigma 2s2.
sigma 2 s 2, sigma star 2 s 2,
Now,
then
now tell me.
sigma
For this one,
sigma, yeah, sigma 2pz,
good, because the energy is
2p2z,
lower. Mm,
then pi 2p 2x,
mm.
then pi 2p2y.
Okay, this is all about it. You have
Then
decoded
what
the.
about the that one, the anti one,
Okay,
anti?
we have to
Yeah,
show
yeah,
them as
yeah,
well.
yeah.
Let us do that.
So how do we do that?
Simply,
Like
simply.
right after?
Uh, we have to follow
Yeah,
the
okay,
order, energy order. After this, we will talk
okay,
about the pi star 2px.
yeah,
Electrons are 1, like we will show it like this. Then pi star
mm-hmm.
2py 1. That's it.
Yeah,
Okay.
yeah.
So what else do we have? Let me see. Are we missing something or not?
Now electronic configuration is having daily updates
It will like this is the last update for you. You won't see anything apart from the last update.
from uh, from 2 comma 8 to 1 is some
Mhm.
like that. Now sigma and pi.
See the initial ones now the 2 comma 8. Those were just for the students, so they don't just freak out. Because if you are in 10th
Yeah.
class, you are just a kid. In 11th, you are again a kid, but I don't know why they just bring the entire actual
It's
science.
gonna be easy if they use the actual configuration in 10th. It could be easy. You don't have to study that in 11th. Otherwise, it's gonna stretch.
But
It would be
like
easy.
in 10th class, there are students who don't want to opt for science, right? In 10th class, there
Yeah.
are students who might be going for arts or commerce, so they don't have to deal with all this. So to
Oh,
make
so
things
it's just
simpler,
like a secret between science and commerce.
just think about it. If you are teaching the same thing that you are learning right now to an art student, he will freak out or not?
Nope.
He will freak out. Just right. Do
Yeah.
you have any friends in arts?
No, in my school, there's no. I mean, I had one.
So
He was smart.
try to teach him molecular orbital theory, right? You will know.
He would already know that.
Nope, you are
He's too
mistaken.
smart. He's like
People,
a
uh,
topper.
intelligence has different
He
domains, right?
knew quantum at the in ninth grade. Think about that.
See, the
He
quantum,
knew that it's gonna come in the ninth grade.
the quantum word, na, people use it to basically show off. When you are a kid, na, you basically used to show it off. But when you actually read
Yeah,
quantum mechanics, na, then you will know
I know
why,
that.
why.
I also did. That I also did. But the amount of he shared was top notch. He doesn't
So,
even do anything. He just goes home, study, and comes to school
so why he is choosing arts? He wants to be a civil servant or
because
something.
he wants to follow his father or something like lawyer or something.
Oh, he wants to be a lawyer, not a bad profession. Oh, yeah. Right. So I am going to share the screen, right? The assignment screen.
Yeah.
So you have to tell me if there is any question that you are not able to understand because we have covered
Okay.
everything from orbital, molecular orbital. So just give me a second. Let us see whether you have actually understood anything or not. Are you able to see my screen?
Yeah. Kind of. Just a minute.
Is it
Yeah,
visible?
I can't see the screen. Now it is. Now it is.
So the first question is, which of the following molecule does not contain unpaired electrons? So what you are going to do to find the unpaired electrons?
What am I gonna do to find unpaired electrons?
Yeah.
Unpaired. Um.
What we call the unpaired electrons, para or dia?
Unpaired electrons. We call them para.
Yeah. So how do you know whether a molecule is a paramagnetic or diamagnetic after after
Number
drawing the
of
entire
electrons. Total number of
after
electrons.
after drawing the molecular orbital theory, right?
Yeah.
So for to answer these, you have to draw the molecular orbital theory. And I am
Mm,
going to mark these questions as homework that I'm going to see before the next class. The next class is after day after tomorrow, right?
yeah.
So you have to complete this. I will check,
And
right?
send you through the
Okay,
not
okay,
WhatsApp. Sorry, the
okay.
website.
The next question. Which of the following order of energies of molecular orbital of N2 is correct? In N2, do we have sp mixing or not?
XP. Which one? Which one?
For N2.
Oh, second question. Okay. Um. Read the question again. Which of the following order of energies? Um.
It is basically asking how, with like the way we arrange the molecular orbitals now while we are drawing the molecular orbital theory.
Oh. Oh,
Which one
like
will have?
that.
So you have to choose the correct option.
N2 N2 is nine N2 has the total number of electrons as 14.
Good. So in 14
Um,
case,
s-
mhm.
so the SP mixing is included.
Okay, good.
So in that case, um, wait. The lowest should be pi star. No, wait. No, wait.
You have the entire cheat sheet, right? Use that.
No, I'm not using that. I know it. Okay, it's between B and C. Let me check B and C.
Mm, okay.
Wait, B and C is same. B and C is same.
Okay, then which one should be the correct answer? And B and C is not the answer, to be honest. See, whenever you have an option to choose from anti-bonding and bonding molecular orbitals, right? The anti-bonding
Mm-hmm.
molecular orbitals will have high energy because they are unstable, right?
Yeah.
The anti-bonding one should be higher. The sign that you are talking about the B and C now.
Mm-hmm.
They are showing that the pi star, the anti-bonding ones are having lower energy. Is there any case where you have seen the anti-bonding one being in lower energy? No.
No, no, no,
So
no.
B and C are not correct.
They're the highest.
So what we can do over here is,
D.
uh, okay, see, you have to submit this as your answer. Again, I'm going to give you the homework. Then I will check.
Okay.
Are you able
It's
to
D, right?
like? Hmm, I don't know. I will check. You might change your answer
No,
today
sorry, sorry,
after
sorry,
your.
sorry, sorry. Yeah, I'm gonna change it now. The actual correct answer is A.
Yeah,
Because
the answer is A.
pi to py is least. I need to like peacefully and take my time to read the whole options.
Good. I'm just showing it here is because I don't want you to like think about like we have missed anything because the every question in this PDF we have covered.
Yeah,
So the next one, B2 molecule is stable molecule or not? You can answer
but
it on the
still
basis of
the B and C are same. Yeah,
the next one, the third question.
yeah,
B2 molecule is not a stable molecule. You can show it by the help of molecular orbital theory or not. The bond order is coming to be.
yeah. It's not a stable molecule. It doesn't even exist.
Yeah. So you can answer all of them. The next question is the which one of the following options represent the correct bond order option? You can take
Mm-hmm.
a help. You have two options to deal with these kind of questions. Either you can draw the entire molecular orbital theory, or you can use the table that I have mentioned, right?
Or mental maths.
Okay. So next. So the moral of this discussion is you have deal with every concept that is given in this PDF. So I am going to give you a lot of questions, and I hope you will be doing them by and before the next class, right?
Yeah, but my school will make up new questions.
No, like you will find similar questions because the concept is same now. If I am talking about Zuhair, they are not going to ask about Adnan, right? Uh, They will
Yeah,
rotate the
but still,
question.
I know they're gonna ask something else. I know that.
See, I
My
told you
four
something.
years of studying, they would put something that is even toppers won't expect.
Okay, for that you can use that. You have your question paper of second chapter or not?
Question paper of second chapter?
You must have given your like unit test or something. You gave
Yeah,
your unit test. We have completed the second chapter, right?
yeah,
Now try to look back and see the questions, the ones that has
okay,
been given by your school. You will find them very easy. Right?
yeah,
So do that. Okay. So do you have
okay.
any questions from your fourth chapter?
No,
Try to
no,
go
no,
through
no.
the PDF. We
So
have 10 minutes.
tomorrow, I mean, day after tomorrow, we're gonna start a new chapter.
We will start thermodynamics. Okay. Before thermodynamics, you are supposed to complete the questions of this chapter because this chapter is pretty important and it is going to give you some decent
Yeah,
marks, right?
it's
So
a big
please
chapter. Yeah,
revise it. And
there's a lot of things.
if you have doubts, by tomorrow, like by the
I'll
next
ask.
class, you have to ask, right? So
Yeah,
we
I
have
will
like
complete this
mhm.
questions.
You have 5 minutes. Try to go through the topics that we have discussed. in today's class. And if you are having anything like, what is this? Like, if you have any doubts now, please ask me. Try to go through the PDF. And
Yeah.
please make a habit of going through my PDF. Otherwise, you